Hi, welcome to this new video. I'm Sergio. We're now going to see how to work with pose estimation. We will focus specifically on building an app to track and count how many squats we're doing as a workout tracker, but we're going to focus on a broader perspective on how to start from an idea and from that to build a project. Why do I want to build this and what do I want to build? Consider that last year I wasn't very consistent with the workout routines that I usually had in the past. I came with an idea of making some sort of leaderboard to keep track of my daily workout. So something very simple like the GitHub, like if you're a developer, this is how, and I'm taking some random accounts from GitHub. This is what we see on GitHub. This is the daily activity for each day of the year, where we have in dark green when you don't do many activities, so like 1, 2, 3 and so on, they have like the dark color, and the shade of the color gets more bright as we do more activities. So it should be something like 100 more activities, we get this very green bright color. And I want to build exactly the same for this app, where, for example, if we do 10 squats, we'll have some very dark color. If we don't do any dark green, if we don't do anything, we will have some dark color like no activity for that day. If we do 100 plus squats or any other workout, could be pull-ups, push-ups and so on, maybe in the future when I will implement to make it more advanced. And I want to have this app always on all the time. So I have this monitor. I want to place a camera on top of this monitor. It will be somewhere on the wall, always on, so each time I pass there, I do the workout, the leaderboard will be updated without me touching anything. And this solves also the problem of having a phone where when you use the apps on the phone where you have to say, okay, today I did 20 squats or whatever, and you have to update it on the phone. I want this to be fully autonomous. This is the main idea of the project. The approach that I have whenever I have a new idea and project is to start as quick as possible without overthinking too much and stuck in the head, and do something practical as soon as possible so that it gives momentum and it will make things more possible to really happen. So today we will build the basic part of this, which will be a simple counter of the squats. Let's start. Now I will start with the code for this one. I'm going to go super fast and I will only slow down with the main challenges of this program, with the core of the program. I'm most likely going to put also an article, so you can check below in the description. There will be a blog post for this video. But if you want the sources, like this is a simple implementation that I'm using of the pose estimation from Ultralytics. Everything is going to be inside the AI Vision Academy. I might tell you a bit more later, but you will find the link down below in the description. And now let's start. We import CV2, which is the OpenCV library. Now we need a capture object, which is the one to load a camera or a video. We will use this one and we will do the pose detection on this video right here. So let's start. So I have this one on the demo folder. So I will put demo and then squats. We have the side squat MP4. Now, the first thing that we have to do always when we work with computer vision is to load either the camera or the video. So while true, we put this into a loop, then ret frame equals cap.read. Now we're going to get in real time the frames from this CV2. Let's show them CV2.im show frame and then frame. If the key is 27, which is this key on the keyboard, we want to break the loop so that we know when we want to quit, we press a key, and that's it. Let's now run this to make sure that we're running the video correctly. So it's running correctly. Of course, we have some error because the video finishes and we're trying to display a frame that doesn't exist. If there is no frame, so if not ret, we want to break. Now I'm going very fast. If you are struggling to follow this, I recommend to start with the basic of computer vision. Everything that I'm showing you, believe me, it's very simple and everyone can learn this. Now, what's the most important part of this app is to detect the pose. What is pose estimation? The pose estimation is where we can detect different key points, like the joints of the entire body, like will be the joints, so like one point on the elbow, one on the wrist, some different key points on the head and different parts of the body. This is an example of what is pose estimation. So from the body we can detect these different key points in real time. There are different models that can perform this one, like this one that I'm showing you right now, it's from Google, but the implementation that I'm making is from YOLO Pose from Ultralytics. So there are different models, and we will not get into the depth of that, but for each different scenarios you might choose a different model. That's not our case for our basic app, where pretty much everything will be fine, especially for a prototype. So now what we want to do, we want to do pose estimation. So we load a pose estimator, estimation, and let's import the module from engine.pose detection. We're going to import pose detection. This is an implementation that I did of pose estimation from Ultralytics. So if you want this, it's in the iVision Academy. You can find different versions of pose estimation online and different models. You need just to understand how to extract the points. That's mostly the most important part. What is pose estimation now? We create a pose detector and then pose detection. Here we choose the model. So from models, we have the YOLO 11 medium pose, that one that I'm using. And now it's very simple. After we get the frame, that's where we put the frame into the pose estimator, and we're going to get the key points and the bounding box of the person. Very, very simple. So we have a key points list, and then we have a bounding boxes equals pose detector. As you see, the Copilot is suggesting me already the rest of the code. Pose detector of detect, and then we want to detect this on the frame. What is this? We have the key points and the bounding boxes. Let's print both of them, print key points list, and let's print bounding boxes. So now you see the video is running. We don't see anything of the video because we're not displaying anything, but we see some print. As you see, we have this, and then we have this. And there are these two different things. One is the key points list. The key points is a list of 17 different points which represent different joints on the body. So here it's an array where we have 1, 2, 3, 4, 5, 6, and so on. We have 17 points. So we have the coordinate of each of them, x and y, and we can show them, and we will see that. And then we have another array, which is the bounding boxes, which is the coordinates of the bounding boxes surrounding the person. So let's now show all of these. So we loop through this at the same time for key points, bounding box, in zip, key points list, bounding boxes. So first of all, we show the bounding box, show bounding box. The bounding box is a rectangle, so x, y, x2, y2. That's what we get. As you saw before from the printing, it was 4 different points. And then we show this cv2.rectangle. We want to do a rectangle on the frame. We have top left point, x and y, right bottom point, x2, y2. And then the color of the rectangle, let's make it green, 0, blue, 255, the maximum of the green, and 0 of red, thickness 2. We have the bounding box, so everything is working so far. But this is not what we need. We need specifically the key points. So let's do that. As key points is a list, we can take key point 1. Let's say there are 17 points, so let's extract from key points. Let's take the first one, let's call it 0, key point 0, and let's display this cv2.circle, key point 0, and then let's make -1 to fill the circle. As you see, we have one key point with the key point 0 is the one on the nose. We could do this for 17 different key points. So we could take key point 1, draw a different circle on key point 1, and we run this one. Now we see some other key points. The second one is somewhere close to the eye. But of course, let's make this in a smarter way. So we loop through all of them for key point in key points, and then we display all of them. cv2.circle, we want to display this on the frame, the key point, the radius, let's make it 5, let's make it bigger so it's more visible, the color red, 0, 0, and 255 maximum of red, and -1 to fill the circle. And now we have 17 different key points that we see detecting different parts of the body. Now, what is important to know which one is the specific key point. So if Now we have a lot of coordinates, but we have just different red dots. If we want to make any app that detects some movement, we need to understand what key point is moving. If that key point that it's moving, it's belonging to the joint of the leg, the knee, and so on. So how do we do this? In order to do this, we need to associate an ID or like an index to each of them, because they have already always a specific position. So the key point 0 will be always the nose. The key point 16 will be always either the right or the left foot, and so on. For this, we just enumerate the key points, and then for I key point, and let's give a text cv2.put text. We want to put the text on the frame. So we display this, we display the exact number of each of them. The position of the text, we put this on the key point. Okay, now it's running, and you see now we have different key points specifically for each part of the body. So the one foot is 16, mostly the ankle is 16, the other 15. Then we have the knees, 14, 13. And as we're focusing on the squat, now let's understand what is a squat. We can take the comparison of these two pictures, so we can consider, like, to make this very simple, that the squat is when you go down. So this is the starting point, the one on the right, and then when you go down like this and you go up again, that's a squat. And that's what we want to count. On the technical point of view, how can we approach this? There is a very simple approach, which is something like this. We have three specific different points we can focus on. The point 12, which is this, which is the right joint of the person right here, the point 14, and the point 16. You see overlapping the point 11, 15, and 13, but they are for the other side. Of course, when you want to build an app like that works fully well, you need to take into consideration many aspects, but for this prototype, let's take the most simple approach possible. Let's focus only on this. What can we do with these three different joints? If we connect them, so like this with lines, we can see something here. We can see an angle, this one right here. And what's the specific of this angle? This angle changes when you do the movement. So that's the key of our program to understand how that angle can be detected. So here is how we get this. And of course here, when the person is standing, the angle will be very different. So this will be the difference in the angle when the person is standing. So to give an approximate estimation, this will be 90 degrees or less. And this will be close to 180 degrees, almost flat. So it's less than that, so it will be around 160 or more. And considering these two values, we can build our tracker app. Let's go now to the technical part of this. What we want now is we want to connect the different points, which are 12, 14, and 16. Then we want to calculate the angle for that. Right here, we can take these three different key points, 12, 14, 16. So let's call this right leg. And now let's display the cv2.polyline. So we have the three different key points. We want to draw this on the leg so that we are sure we are targeting the right part. So we draw them on the frame. Then we have the sequence of, we have the right leg. Mixing some color, 125, thickness 2. Is the polygon close? False. Okay, as you see now, we are detecting the leg. So you see, I didn't choose the right color because it's almost matching the trousers, but it's still visible. So we have a line right here. What should we do now? We need to get the angle, because that's the key part. So now we know that we are targeting the right part. Let's get the angle from the point 12, 14, 16. In order to get the angle, we need some mathematical formula, and this is the right moment to use some sort of copilot, like would be GitHub Copilot or ChatGPT, because this is where it works very well. When we need something very specific, it's geometry, it's mathematics, so it will give us a simple function to do this. So I can ask to ChatGPT or Copilot, so I have also the Copilot here, and we can ask straight, give me a Python function to calculate concave, so that we want a small angle starting from 3 points. So we have point 1, point 2, point 1, point 2, point 3. We want the angle on point 2, 16. So we have 1, 2 and 3, and we want the angle of 0.2. And let's see what we get. So we have this function, and while Copilot or GPT are not great when you give like some big project when things are not very clear, for such functions they save you a lot of time and energy for your project, and it's highly recommended. So let's now test the function to be sure everything is working correctly. So as I asked in the instruction, we give 3 different points, right knee angle equals calculate concave angle, and we need to give the 3 different points. We have right leg 0.0, 0.2. So let's run this and let's see how it's working. So we have this printed in somewhat yellow. You see the number is changing. It was my mistake. Instead of use the convex angle, I'm using the outer angle. So instead of getting this internal angle, we're getting the outer angle. Okay, now we ask for the convex angle, and now it will make some adjustments. Okay, and it's now running with the fixing with the convex angle. You see, when it goes down, the angle comes as low as 75. When it goes up, it's very close to 180 as we estimated before. That's what we mostly need. And so once we have this, we're very, very close to making our app work, because we can know the movement. So when the angle goes down and up again, then we know it's a squat. That's it. That's as simple as that. What everything we have to do. Now we could put this now the counter for the squats in the same file, but it will be a bit messy and disorganized. So I created another empty file, and then we will import the function into this one. So it's called workout counter. Let's create a class which is called squat counter. Then we want to store the total reps, self total reps, and of course the counter will start from 0. And then let's make count, def count. We need the angle, and of course if you're not familiar with this, I recommend to go back to the Python basic. It's very simple to follow. The creating class or function, but it might be a bit abstract to follow if you're not familiar with this. Anyway, you can still follow and understand like the concept of the counting. So the count here, we need the angle, and at the same time we need to know if the person is going down or going up. So I will say self dot down is false, so we can activate and deactivate this variable so that we can keep track of the movement. If the angle is less than 90 degrees, so we can keep 90 degrees, and self dot down is false. So if we're going down, if it's less than 90, it's not self down. So we want to activate and say, okay, if it's less than 90, we activate and we say now we're going down. So we say self down equals true. And if the angle is greater than 150 degrees and self down is true. So that's why we need self down, because so we know if we are going up or not. Otherwise, each time if we are standing and the angle will be 150, it will be just counting non-stop. So that's why we need this. So we need a switch button to say, okay, now we're going up. So self down equals false. Of course, here we increase. So self dot total reps plus or equals 1. And then we return the self.total reps. As simple as that. We don't need anything more on this. So if we go back now, right here, now let's make the count. From workout counter, we import squat counter equals squat counter. So we created a class, so we need to create the object for the class. And now here we can use it. So squat counter dot count, and we give the angle, right knee angle, and right here total reps. And now let's show that in real time. On the top left, you see we have a counter which is starting from 0. So when the person goes down and comes back up, we should see the count increase. And we see 1, 2, 3, and so on. As simple as that. As you can see, the approach, like the project, of course, it requires now some complexity and some structure, but you see, to make some very basic prototype, it didn't took long. We make this in 1 hour or something. Like, The video is a bit less with the cutting, but that's the average that it takes. The sources for this, and together with a different program like with the basic of computer vision and so on, you can find everything inside the AI Vision Academy. It's also a community. You can interact with all the members. I will be there. We have monthly coaching calls and so on. If you want to stay updated with this series, and if you want me to also develop the user interface part like this one and all together the entire program, let me know in the comments so I can bring more video about this. I hope that you enjoyed this video and that you got a lot of valuable information from it for your project. This is all for now. See you in the next.